Okay. Good morning, all. From last few lectures, we are discussing related to the powder metallurgy concept. In last lecture, we have completed the powder metal. What is the meaning of powder metallurgy? Then, what are the different methods of manufacturing the different kinds of the powders? And what are the different steps involved in the powder metallurgy technique? With help of means whichever powder we have manufactured, with help of that, we can manufacture the component with desired shape and size and with desired compositions. Now, in this session, we are going to discuss means few practical examples. This manufacturing of the few components along with their flow charts. Okay, in that we are going to see the manufacturing of self lubricating bearing, then cemented carbide cutting tool, and after that we are going to discuss the manufacturing of the friction material. From these three components, they will ask you the manufacturing process of any one component. Compulsory, this question will be there. Either they will ask you self lubricating bearing or cemented carbide cutting tools or friction material. From these three, one compulsory question will be there. And while explaining its manufacturing process using powder metallurgy technique, you have to explain it with the help of flow chart. Okay, so here I have collected the flow chart. These are the actual symbols which you have to use for that process. Okay, I mean, so different processes are there as we have discussed in the previous lecture. That is, powder metallurgy technique will consist of different stages. The first stage will be powder production, then after that mixing, then compacting, or you can say that pressing, then sintering, sizing or machining. Then there are during the sizing, sometimes after performing the sizing, you can do impregnation, infiltration processes, and at the end you have to do the testing and inspection, and after that you will get the your desired component. Okay, sometimes there may be some addition of few extra processes that I will explain with the help of the charts. Okay, these charts I have collected from the reference book. Okay, these charts are not available in the VD code gray book. Okay, for getting these charts you have to refer Auner physical metallurgy by Auner. In that book you will get to find this chart. Okay, I have taken this picture from that book only. Okay, now the question will be like this. They will give you the name of the component. Suppose self lubricating bearing. You have to explain the manufacturing of self lubricating bearing using the powder metallurgy technique with the help of flow charts. Now, whenever they are asking you to draw the flow chart, now for each process, the fixed symbol is there. First, I will explain the symbols according to the process. Okay, now we will go one by one. Okay, this will be in simply the first stage will be your powder production. Now, simply the powder production, you can draw one box, means a rectangle, and you can say that you can indicate the powders directly there and manufacturing of that powder, or you can directly start with the mixing process. Okay, for powder production, particular symbol is not available. That is not shown in these diagrams. Okay, is it visible? First, let me clear it. Please provide me reply whether these diagrams are clearly visible, diagrams and their names.
Yes, sir.
Okay, okay. Okay, then we will start. Okay. For first stage, I will explain with the help of this diagram. Okay. Now, you're in any while manufacturing any component with the help of the flow charts, first stage will be your powder production. Now, powder production simply here I have not means in that book that they have not shown that powder production stage. Directly they have indicated the name of the powders in the mixing stage, and simply you can draw one rectangle here, and you can indicate the name of the powders manufactured. Okay, and if you are in that, you have to mention which powders you are using, and for manufacturing of that powder which method you have used. Okay, we have discussed that there are four different methods, and that mechanical method processes, physical processes, chemical processes, electrochemical processes. From that, whichever powders you are using for that powder, which process, manufacturing process you have applied there, that you have to mention in that powder production stage. Okay, just simply draw the rectangle. Now here I have drawn it horizontally. You have to draw it in the vertical manner. Okay, you have to draw the same diagram in vertical manner. Okay, at the start you have, this is horizontal. Okay, you have to draw it vertical and indicating the downwards arrows. Okay, you have to start with one rectangle showing the powder production stage, indicate the powders used and which method you have used to manufacture that powder, you have to mention it. Then for mixing stage, okay, this is the symbol for the mixing stage. This is symbol for rotating drum. Okay, simple symbol is there, rotating drum symbol is there for mixing stage. And you have, below that you have to write the name and powders used along with the whichever binders or lubricants you have added, that you have to mention here. Then after mixing, the next stage will be the pressing. For pressing stage, this symbol you have to indicate. Okay, this is the die cavity and this is the punch, and on that you are applying the pressure. Okay, this is the symbol for the pressing or compacting operation. Then this is the symbol for the sintering. Just forget this temperature values. We have to provide the temperature values in the degree Celsius. Okay, they have provided the values in the Fahrenheit here. Forget it, or just neglect it. You have to draw it in the degree Celsius. Okay, just try to remember the symbol, just capture the symbol which they have used here. This will be the symbol for the sintering. Now proper care you have to take here that in some components pre-sintering process will be there. Okay, in some components pre-sintering and sintering will be there, means two sintering processes will be there. In some components pre-sintering will be there, and again sometimes the two types of two different kinds of the sinterings may be there. Okay, means like preliminary sintering, secondary sintering. Okay, number of types of sintering processes may be there, but same symbol will be there. Just you have to write the name. If suppose pre-sintering is there, then below that you have to indicate pre-sintering, and in this box you have to indicate the temperature used. Okay, or suppose preliminary sintering or final sintering or secondary sintering, different names will be there. Just you have to write the name, symbol will be same, and you have to mention the temperature here. Okay, just temperature values will get changed and name will be changing, okay, according to your component. Okay, so this is the symbol for the sintering process. Then after the sintering, the next stage is the sizing, machining. You can say the sizing or machining, or sometimes you are in specific components you are using the wire drawing operation. Okay, for the all these processes you have to use this symbol. Okay, it will indicate the change in the dimension. This is the symbol for machining or sizing. Okay, you have to remember, try to remember these symbols. This is the symbol for sizing, machining, or suppose you have used extra wire drawing operation, you have to draw this symbol, and just below that you have to write the name of that process. Okay, and after that the end process will be testing and inspection. Now depending on the component, some extra processes may be there, like in this self lubricating bearing, some extra process, that is impregnation is there. Just you have to write a simple rectangle. Below that you have to mention the that name of that process and temperature, whichever temperature you have used. Okay, if any extra process is there, simply add one blank rectangle, mention whichever parameters you have used there, and below that you have to write the name of that process. And at the end, uh, you will, after testing and inspection process, you have to add here, and at the end you will get your finished product. Okay, so these are the symbols used for different stages. Okay, for powder production, just simply you have to write one rectangle, and whichever powders you have used and which methods you have used to manufacture that powders. Okay, just that you have to mention there, and below that you have to write the name powder production. Okay, then after that, this is the symbol for mixing. Simply symbol, why this symbol is used, it will indicate the rotating drum. This is the, then this is the symbol for pressing or compacting operation. Okay, why this symbol is used, this is the die cavity and this is the punch, and on this you are going to apply the pressure. Here you have to mention the pressure values. Okay, depending on the component. Then this is the symbol for sintering. Okay, same symbol you have to use for pre-sintering, sintering. Then any kind of sintering operation will be there, preliminary, secondary. The same symbol you have to use. Just mention the temperature and here atmosphere. Generally, reducing, or you can say that neutral atmosphere is used, or reducing atmosphere is used. Okay, already that we have discussed in the previous lectures. Okay, then this is the symbol for sizing, machining, or wire drawing operation. Then the remaining operations like impregnation, testing, inspection, simply draw one rectangle. Below that you have to write the name of that stage, and whichever parameters or temperatures you have used, you have to indicate that in this box, and at the end you have to write the name of your final product. Okay, so in this way, this is the concept, that is which symbols you are going to use for drawing the flow chart. Okay, now why I have explained this, if you understood which symbols you are going to use, then just you have to understand, for suppose three products are there, which steps you are going to use. Okay, just you have to memorize that steps, and for each step which parameters you have used. Okay, which parameters or which powders you have used, just that you have to remember. And remaining description, you can write whichever we have discussed in the previous lecture, that is different steps in the manufacturing of component using powder metallurgy technique. The description will be same, just the parameter or values will be changed. Okay, or you have to indicate the specific values. Here I will now you will get the clear understanding when I will explain the first component. Okay, so here now please you can write this part. This is very important. The flow, you can write the heading flow chart for manufacturing of, you can say that porous bearing, or it is also known as self-lubricating bearing, or it is also known as oil impregnated porous bearing. Okay, and these are the steps involved in the manufacturing of the self-lubricating bearing by powder metallurgy technique. Okay, first you have to write the steps, just sequence, in the sequence. First stage will be powder production, then mixing or blending, then compacting, then one pre-sintering operation will be there, then sintering operation will be there, then sizing or machining, then impregnation, and finally testing and inspection operation is there. Okay, now whichever diagram is available in that Avner book, you can clearly see here that they have not mentioned the pre-sintering process. Now, while writing your answer, you have to add the same symbol two times, and first you have to indicate pre-sintering, and after that, next, for next symbol you have to mention the sintering process. Okay, just temperature will get changed. Okay, now please write down this part, name of the component. Okay, and the stages involved. And as I'm explaining it, just mention the or you have to write down the whichever parameters or specific powder names we are using in the manufacturing of this self-lubricating bearing. We just draw this diagram. I will wait for a few minutes. In this diagram, you have to add the first, here in the first stage, before this mixing, you have to add one rectangle, and you have to mention the powder production. Okay, powder production, in that you have to mention copper and tin, manufacturing of copper, tin, and graphite powder. You have to mention that. Okay, just write one rectangle, and in that make three arrows, and manufacturing of these three powder names you can write there. And after that, draw one arrow, and after that you have to write the mixing, then pressing, and here draw this symbol two times. And for first symbol, give the name pre-sintering, then sintering, and after that remaining part will remain the same here, sizing and machining, then the impregnation. And after this, here you have to add one rectangle, and below that write testing and inspection. And after that you will get the self lubricating bearing or porous bearing. Okay, I will wait for a few minutes. Please draw that diagram. Okay, I will wait for a few minutes here. Please draw that flow chart. If you practice here, your means this question is compulsory there. You can check any question, previous question papers. Okay, and there are some means in gate examination also they have asked some questions related to this. I think this impregnation process they have asked this question in the gate examination. If exactly I will tell you the year in which they have asked that. In gate 2011 they have asked the question related to this impregnation process. Okay, and they have asked in 2000, 2012 the question related to the applications of the powder metallurgy. They have provided one component's name. I can tell you that question. Okay, while drawing that diagram, I will tell you a few questions. Okay, or just draw that diagram. I will wait for few minutes here, and after completing that diagram, please mention that in the chat box that you have completed it. Okay, and you have to draw it according to the changes which I have suggested here. Okay, at the first here add the powder production stage, then here pre-sintering and sintering will be there, and after impregnation process here testing and inspection process will be there, and at the end your final component will be there. Please draw it. I will wait for a few minutes here, or I will wait for 5 minutes. Okay, exactly 5 minutes I will provide you. Please complete that diagram. Okay, these symbols will remain constant. Okay, symbol for a process will remain constant. Just their pressure values, suppose in mixing stage or in powder production, powders will get changed. Mixing will remain same, just you are using same equipments there. Then pressing pressure values will get changed. In the sintering temperature values will be different. Okay, and there may be some extra processes will be there depending on the component. Okay, please draw it. I will wait for a few minutes. After drawing, please mention that in the chat box. Okay, please provide me replies whether you have completed the drawing. Okay, uh, yeah, only one student is giving reply. Okay, whichever diagrams you have drawn, just send me the screenshot of that diagram on my WhatsApp. Okay, I'll check it whether it is proper or not. Okay, um, I think you may have completed the drawing. Okay, now I will explain the actual manufacturing of this first component, that is the self-lubricating bearing, with the help of this powder metallurgy technique. Okay, shall I start? If you have finished the drawing, shall I start? Please provide me few replies so that I will explain it. Okay, okay, we will start then. Okay, now this self-lubricating bearing, this is also termed as the porous bearing. Now, why the name of porous bearing is given at the end of that process, you will uh, understand that why these names are given, like porous bearing, self-lubricating bearing, or it is also known as oil impregnated porous bearing. Okay. Now, the manufacturing of this bearing, it consists of following stages. Approximately 8 stages are there. First stage is the powder production stage. Second stage is mixing or blending. And third stage is compacting or pressing. Fourth stage is pre-sintering. And fifth stage is sintering. Then sixth stage is sizing or machining. In some books, they have mentioned resizing also. Okay, sizing, machining, or resizing also. Sometimes they have given that name. In some books, quining name is also given. Then the seventh stage is impregnation stage. Okay, then eighth and last stage is testing and inspection. Okay, now I will start one by one. Now the first stage is the powder production. Now here this is very important part, that in this part you have to write the exact composition which you are going to use for manufacturing of this self-lubricating bearing. Okay, Arjun, this self-lubricating bearing can be manufactured with the help of brass, then bronzes. You can use the different kinds of brasses. If different kinds of the bronzes are there, you can use that. Then you can use iron or aluminum alloys also to manufacture this self-lubricating bearing. But generally, we are using the bronze. Okay, bronze is used for manufacturing of this bearing. Bronze, in the sense, we are going to use the mixture of copper and tin powder. Okay, this will be your first point. It is production, powder production. Here powders required will be copper powder, then tin powder. Okay, copper, Cu, symbol for copper is Cu, then tin powder, symbol is Sn, and graphite powder, that is the carbon. Okay, carbon in the form of graphite. Okay, these three powders are used. Then copper will be approximately 90% copper will be there, tin will be 9 to 10% tin will be there, and very small amount of graphite is added. Very small amount of graphite is added here. Now these three powders we are going to use: copper powder, tin powder, and graphite powder. Approximately 89 to 90% copper powder will be there, 9 to 10% tin powder, and very small amount of graphite will be there. Okay, this will be your first stage. And in that you have to mention that for manufacturing of the powder, that is to manufacture copper and tin powder, you can use electrochemical process. Okay, electrochemical process, that is electro deposition process, or you can use the chemical process. From that chemical process you can use the precipitation from aqueous solution. Okay, you can take note of it. That is, for manufacturing copper and tin powder you can use electrochemical process, that is electro deposition process, or you can also use the simple displacement method, which is a subtype of chemical process. Okay, or that simple displacement is also known as precipitation from aqueous solution method. Okay, so these are the methods used to put. Just you can write that in your diagram also. Okay, just write down that. Okay, so this is our first stage, powder production. Then after that the second stage is the mixing stage. Okay, for powder production, to indicate that stage, just before this mixing stage, here you have to draw the one rectangle. Okay, one rectangle, and in that you have to mention copper, tin powder. Copper approximately 90%, tin will be approximately 10%, and very small amount. Okay, tin will be 9 to 10%, and very small amount of graphite powder will be there. And these powders will be manufactured with the help of electrochemical or electro deposition process, or you can use the chemical processes. From that chemical process you can go for simple displacement process. It is also known as precipitation from aqueous solutions. Okay, and then next method is the mixing. Now whichever powders, this copper, tin, and graphite powders are there, or initially here there is no need to mention that graphite powder. You can directly mention that here also, because you are adding that graphite as a lubricant. Okay, if you mention in the first stage, it will be also okay, no problem will be there. In the next stage, this is the mixing. Just you have to draw one drum like structure. Okay, now here you have to mention copper, tin, and graphite powder. In this mixing stage, here we are going to obtain the homogeneous, uniform and homogeneous mixture of copper and copper, tin, and graphite powder. Now here you have to explain that why this graphite is added here. Okay, this graphite is added to provide the necessary lubrication during the next stage, that is the pressing or compacting. Okay, this graphite will act as a lubricant, and this graphite, after pressing operation, this graphite will be removed by performing a pre-sintering operation. Okay, that you have to mention here. Uniform and homogeneous mixture is obtained of this copper, tin, and graphite powder. And here you can mention that whichever part you have studied in the mixing process, you can use the different equipments, that different mixers are there, or different drums. Rotating drum is there, blade mixer is there, screw mixer is there, or Y cone blender, double cone blender. Any instrument can be used to get the uniform, to obtain the uniform and homogeneous mixture of this copper, tin, and graphite powder. Okay, this will be your mixing stage. Then the third stage is the compacting. After that, whichever third stage is compacting. Okay, this uniform and homogeneous mixture of copper, tin, and graphite. Here in the compacting process, you have to explain this compacting. With that, three stages involved in that compacting. Okay, here just pressure we are using. That's why this is pressing or compacting, or simply you can say that this is the cold compacting process. Okay, cold compacting. No heat is used in this compacting process. That's why you can say that this is the cold compacting. Then now in this pressing or compacting stage, you have to explain the three different steps which are occurring here. That is filling of this uniform and homogeneous mixture, filling in the die cavity, then pressing, sufficient amount of the pressing, and after that the ejection method. Okay, ejecting the component from this die cavity. These three stages you have to explain here. Okay, I will explain it in short. The uniform and homogeneous mixture of this copper, tin, and graphite powder is filled in this die cavity. Okay, with the help of a hopper or feed shoe, you can say that. Then the volume can be adjusted by raising or lowering that plungers. Then this is the filling process. Then pressure can be applied with the help of only one plunger, or you can use the both plungers or punches. Okay, now here pressure values applied should be, here you have to mention the pressure values. Okay, now the pressure values used for compacting in the self lubricating bearing is in the range 20 to 50 kg per millimeter square. Okay, that you have to mention here in on this bar. You have to mention here 20 to 50 kg per millimeter square amount of pressure is used to get the sufficient amount of pressing. And after that the component is ejected with the by raising the lower plunger, and a green compact is obtained, or simply a compact is obtained. Okay, and during this stage of compacting, density of that component will get improved. Then you can say that the voids between the powder particles will get reduced. And sometimes there may be some addition between the powder particles addition, or in some books they have mentioned the you can say that some small kind of the welding will get occur there, will occur there. Welding is nothing but attachment between the powder particles due to the pressing. These all processes will take place here. You have to mention the pressure values. 20 to 50 kg per millimeter square pressure is used here. Okay, and after at the end you will get a compact. Now the next stage is the pre-sintering stage. Okay, on that compact you have to perform a pre-sintering process is performed. Now what is the aim of that pre-sintering? Just now we have to eliminate this graphite powder. Now the role or function of this graphite powder is finished. That is to provide the lubrication during the pressing or compacting process. That work is done. Now if it get carried forward to the end product, it will reduce its strength. That's why you have to eliminate that graphite powder. Okay, then it is eliminated by performing a pre-sintering operation. Now this pre-sintering operation is performed at 400 to 450 degrees Celsius. Okay, and its time will depend on the shape and size of that component. It may vary from some 30 minutes to 2 hours. Okay, depending on the shape or size of that component. Okay, pre-sintering is done at 400 to 450 degrees Celsius temperature range to eliminate that graphite powder for approximately 30 minutes to 2 hours, depending on the shape and size of that component. And during this pre-sintering, that graphite powder will get eliminated. Okay, here you have to use this same symbol. You have to write pre-sintering, and here you have to mention the sorry. Here you have to mention the temperature 400 to 450 degrees Celsius, and here you have to mention the reducing atmosphere. You can write that reducing neutral atmosphere. Okay, then after doing the pre-sintering process, the next stage, the component or that component is subjected to the sintering process. Now in this sintering stage, one more symbol, same symbol you have to draw below that sintering name. We have to write, then reducing atmosphere you have to mention, and here the temperature will get changed. Now um, after pre-sintering, that component is subjected to the sintering process. Here the component is heated at uh, about 800 degrees Celsius. Okay, and for this here the sintering is performed for only 5 minutes. Okay, You have to remember the time values. Okay, temperature and time in case of the sintering process. Okay, it is this component is heated about for at about 800 degrees Celsius just for 5 minutes. Okay, and what will happen during this sintering process? Okay, now whichever here we have two types of powders are there, copper and tin. Graphite we have eliminated. Now copper and tin powders are there. Okay, now from this copper and tin at 800 degrees Celsius, this tin powder will start melting. Okay, it will start melting. Now due to this melting, what will happen? These tin powder particles will get diffused on the copper powders. This is the diffusion process. Then due to this diffusion, there will be some reduction in the size of that component, which is termed as the densification process. Okay, due to the diffusion of tin powder particles on the copper powder particles, diffusion will occur, and due to that diffusion, the component is subjected to some distortion or densification. And due to the melting, or you can say that diffused, due to the diffusion of the tin particles on the copper, that copper will absorb it, and formation of or you can say that recrystallization will occur and formation of new grains, and it will occur here. Okay, in this way, during the sintering, diffusion densification is occurring here, along with recrystallization and formation of new grains will take place here. These all stages will occur, or all these processes will take place in the sintering. Now that sintered component here, there will be some changes, distortion in size due to the diffusion process. Now that you have to identify, and depending on the desired, whichever desired shape and size is required, according to that you have to go for sizing or machining operation in the next stage. Okay, now the sizing or machining operation is performed. It is also mentioned as the resizing in some books. Okay, resizing, sizing, or machining. And this can be performed with the help of a master die. A master die can be used with the help of two punches, or you can say that plungers. Okay, and its size rectification is done. That is termed as the sizing. Or sometimes you can go for direct machining operation to get the desired shape and size. That is the machining operation. And after getting the desired shape and size, the next stage is the impregnation. Now on the surface some pores are there. That pores are filled with the help of oil. Okay, you can go for cold oil or hot oil also. Okay, you can use cold or hot oil to fill the pores which are present on the surface. This process will be termed as the impregnation process. Okay, here we are filling the pores with the help of cold or hot oil. If hot oil is there, the temperature will be 100 to 180 degrees Celsius temperature. Okay, just forget this temperature values. You have to indicate whichever temperature values I am telling you, that you have to mention for impregnation. Cold or hot oil can be used to fill the pores present on that surface. And if you have used the hot oil, its temperature may be in the range of 100 to 180 degrees Celsius. Okay, so this is the impregnation process. And after completing this impregnation process, this whichever component is there, that is subjected to the various testing processes or various testing methods. In that you can go for different destructive testings or non-destructive testing methods to determine its strength, its hardness, then what is the amount of the porosity, then what microstructure exactly is there. Then you, okay, that you can do different testing methods. And you can also perform the inspection operation. That is, you are going to check its shape, size, and whether any kind of defect is present in that component. All this checking is done in this testing and inspection. And for this you can go for different methods available. It may be destructive testing methods or non-destructive testing methods. Okay, and at the end you will get the your final product, self lubricating bearing. Okay, so these are the stages involved in the manufacturing of this self lubricating bearing. Now, why this bearing is termed as the self lubricating bearing? because in the impregnation process we have already provided, or the pores are already filled with the oil, and when you are using that component in the actual practice or actual service, no extra lubrication is needed there. Automatically during the functioning, this oil will be released and it will act as a lubricant. Means there is no extra lubrication is required for this kind of bearings or components manufactured here. That's why these bearings are termed as self lubricating bearing, or these are termed as porous bearings, or as we have impregnated the oil, or we have filled the pores present with the help of oil, it is also known as oil impregnated porous bearings. Okay, because it does not need any further lubricant. It will mean self lubrication will occur there, as we have performed or filled its pores with the cold or hot oil by impregnation process. While actual application or practical use, that oil will be act as a lubricant there. Means self lubrication will occur there. That's why it is termed as self lubricating bearing. Okay, so this is the explanation of this bearings. Now, uh, whether you have understood this part, these stages, and then after this, I will explain the some properties and its applications. You have to mention some properties of these bearings obtained, and you have to mention some applications also. Please mention that in the chat box that these points are clear, so that I will move to the next. Okay, please mention that in the chat box. Okay, now after explaining this, just you have to mention in the short, that is what are the properties in this self-lubricating bearing. Two, three important properties you have to highlight, and after that you can directly go for the application part. The properties which are there in this bearings are here they are having sufficient porosity. Okay, uh, after the sizing or machining, they will have sufficient amount of porosity, approximately 30 to 50% porosity will be there. So due to this porosity only, you can means you, in this impregnation process, you can add the oil in that pores. Okay, why you will be able to add this oil in the large amount, because it is having 30 to 50% amount of the porosity. 30 to 50% porosity will be there, and you can add the sufficient amount of the oil. Due to that porosity, it is having sufficient oil retaining capacity. This is the first characteristics or property. Then it will provide you the required strength also. Okay, due to that pressing, centering, sufficient amount of the strength will be there to carry the required load or desired load will be there. Okay, so sufficient porosity, 30 to 50% porosity will be there to acquire or to retain the sufficient amount of oil. Then sufficient amount of the strength will be there to carry the load. And third important is you can give the means dimensional accuracy obtained is very good. Means whichever dimensions are required for your use, you can give that dimensions, or you can manufacture the bearing with the dimensions required. Okay, means in short you can mention that dimensional accuracy is very good, or good dimensional accuracy. Okay, now related to its application, depending on that porosity only, you have to choose the application of this bearing. Now generally these bearings are used where you cannot do the suppose external lubrication cannot be added due to some for example, you can say that suppose the food industries or chemical industries are there, you cannot do the external lubrication there because that whichever foods or products are there, they may get contaminated. Okay, uh, in that industries, in the whichever machineries are there in that food industry, and then chemical industries, or you can say that different textile industries are there, textile industries, food industries. In this, whichever bearings are required in that machinery, that bearings will be manufactured with the help of this process only, or that bearings are self-lubricating bearings only. Then you can say that the different bearings which we are using in our automobile sector. Okay, in automobile sector, suppose in our vehicles, you can say that that sliding doors are there, wipers, sliding doors are there. Okay, in that, in whichever vehicles we are using, it may be our two-wheeler or different cars, buses, trucks and tractors are there, there may be some sliding doors may be there. Then you can say that different brakes and clutches are there, in that bearings will be there. And that bearings are manufactured, or that bearings are nothing but the self lubricating bearings. Okay, in different vehicles, the sliding doors, brakes, clutches, and that different components, or sometimes when wipers are there, some bearings are required there. That bearings are nothing but the self lubricating bearings. Okay, these are different applications in the different machineries of food, textile industries. We are using this self lubricating bearing. Then in different vehicles in the automobile sector, in the cars, buses, trucks and tractors, in that, in the brake, different kinds of brakes, clutches, then you can say that sliding doors, and some starters are there, some wipers are there. In that bearings are required, and that bearings are manufactured with the help, and that bearings are nothing but these self lubricating bearings are used there. Okay, these are some applications. Now well, before deciding the application, some parameters you have to use, and that parameters will be like this. It's suppose the porosity obtained is very high. Whenever porosity is very high, please listen it carefully. Whenever porosity is very high, then its oil retaining capacity is very high. Then due to this very high oil retaining capacity, its strength will be little bit less. Okay, it will provide you high oil retaining capacity, but strength will be very less, that is load carrying capacity is less. That's why that kind of bearings are suitable for high speed and low load applications. Okay, whenever porosity is more, its oil retaining capacity is more and load carrying capacity is less. That's why these bearings are used for applications which are having high speed and low load conditions. Okay, this is the first part. And the second part you have to decide, that is whenever porosity is very less. When porosity is less, its oil retaining capacity is also less, but its strength will be more, that is its load carrying ability is more. Then these kind of bearings are used in the low speed and high load conditions. Okay, low speed and high load conditions. Okay, these two parameters are used for while selecting the application of that bearing, depending on its porosity. Okay, depending on its porosity, its oil retaining capacity and load carrying capacity will change. Okay, depending on that, you have to select its suitable application. Okay, and some practical applications also I have mentioned that you have to write at the end. Applications, you have to compulsory mention the applications. Okay, in this way this part is completed. That is the manufacturing of self-lubricating bearing or oil impregnated porous bearing, okay, using the powder metallurgy technique and with the help of the flow chart. Now the next component I will take diagram. Wait, I will add it. Okay, wait for a few minutes. Huh? It was not saved. Previous data is not saved here, I think. Okay, I will add that. Please wait for a few minutes. Huh? Okay, so we will continue with this. Now, this is the next component. That is the friction material, or it is also known as the sintered friction material. Okay, sintered friction material. And now the steps involved. The first step, um, I will explain the stages. Whichever flow chart according to that stages will be there that you have to write. Okay, some steps will be very less as compared to the self-lubricating bearing. That pre-sintering and the impregnation step is not here. Okay, and remaining stages I will explain. Now here, while manufacturing this friction material, in some books they have also mentioned this sintered friction material. It is also known as sintered friction material. Now these powder metallurgy components, because we are performing or whichever strength and hardness is there in this powder metallurgy component, that is obtained due to that sintering process. Okay, that's why these components are also termed as sintered components. Okay, powder metallurgy components are also known as sintered components because whichever properties and that strength and hardness properties we are obtaining or densities we are obtaining high density values that are obtaining getting due to the sintering process only. That's why these are also termed as sintered components. Powder metallurgy components are also known as sintered components. Okay, just sintered name will be there. Sintered friction material. So don't get confused if they provide you the name sintered friction material like that or sintered another component, sintered gear like this. These are powder metallurgy components only. Now here, now in this friction material, whenever you are manufacturing this friction material, you have to take the proper care that there should be properties. You have to mention some properties also, okay, at the end. But here I will explain you the properties at the start only. Now, whichever friction material you are going to manufacture. Now here it should be able to give the sufficient corrosion resistance. Then it should have good thermal conductivity. Then it should have sufficient coefficient of the friction. Okay. And there should be, it should not cause more wear and tear, okay, while you are going to use it. As friction material is there, it should be subjected to the more wear and tear. That this material should be manufactured in such a way that there should be minimum wear, means its wear resistance, its corrosion resistance should be high, and it should have good thermal conductivity, and it should have sufficient coefficient of friction also. Okay. So these are the some properties you have to mention. Okay, you can mention it at the start or you can mention at the end also, properties achieved and this friction material or properties of friction material, and after that you can write few applications also. Okay. Now at this now here the first stage is the powder production stage. Okay. In the powder production stage, you have to write that whichever flow charts I have explained the symbols. Okay. I explain the symbols that you have to use it. Okay, I will take this diagram for a reference. Okay, leave it. Just to try to remember the symbols, and you have to draw it by your own. Okay, these two diagrams, for diagram for friction material and the third component also, that is the cemented carbide cutting tools. That all these three diagrams for self lubricating bearing, friction material, and cemented carbide cutting tools, for all three components you have to draw the flow chart and complete that flow chart. I will explain the process, and in that flow chart mention all powder particles used, then the compacting pressures used, then sintering temperatures used, mention that. And at the end you have to send it to me via WhatsApp, or you can email it to me. Okay. Now I will explain it. Now to manufacture the friction materials, here different powders are used. Okay. Here we are going to use copper powder, then tin powder, then lead, graphite, silica, and iron. Okay, I will repeat it again: copper powder, copper, tin, lead, graphite, then iron, and silica powder will be there. Now, proper care you have to mention here that copper and tin, whichever weight percentage is there, whichever powder mixture we are using here, 90% weight percentage will be of only copper and tin. Okay, 90% weight. If you take the weight ratio, the copper and tin will be 90%, and 10% amount will be of remaining four powder, that is lead, graphite, silica, and iron. Okay, lead, graphite, silica, and iron. 10 to 20%, and 80 to 90% amount will be of only copper and tin. Okay, 80 to 90% amount of will be of copper and tin, and this is the weight ratio. Okay, don't get confused. You have to mention that in the weight ratio, copper and tin will be 90%, and 10% weight will be of lead, then graphite, silica, and iron. Okay. Now these powders can be manufactured by using the suitable methods. You can go for using the electrochemical processes or chemical processes. Sometimes for manufacturing of the iron, you can go for thermal decomposition, that is the physical process also. Okay. So this you have to mention in the powder production. Okay. I will repeat it again. The powders used here: copper, tin, and in weight percentage of copper, tin will be 90%. Then lead, graphite, iron, and silica, the four powders togetherly will be 10 to 20% according weight percentage of these powders. Copper, tin 80 to 90, and remaining four powders, lead, graphite, silica, iron, it will be 10 to 20%. Okay, this will be your powder production. And after that you have to do the mixing or blending operation, obtain uniform and homogeneous mixture. Okay. You have to obtain the uniform and homogeneous mixtures. Now here, as the large or different powders we are using here, numbers are more. Okay, 5 to 6 kinds of powders are there. Due to the large difference in the densities, due to large difference in their densities, some segregation may occur. Some powders segregation may occur. Okay, proper mixing may not take place. That's why to obtain the proper mixture, you have to add some oils here. Okay, some small amount of oil may be added to avoid the segregation. Okay, and if you have mentioned that segregation, to remove that, to avoid the segregation of some powder particles, if you have added that oil, then you can do the remove that oil after the compacting process. Okay, remove that oil after the compacting process by performing one, you can say that the simple pre-sintering operation. Okay, so this is the mixing. Uniform and homogeneous mixture is obtained with the, you can say that, with the help of different kinds of the mixers or different kinds of the blenders. You can use icon blender, double cone blender, or you can use different kinds of the mixers are there. You can use screw mixer, blade mixer, or you can go for rotating drum also. Okay, then after this, the next stage is compacting. Whichever homogeneous and uniform mixture is obtained, that is, you have to perform the compacting or pressing operation. Here the compacting, sufficient amount of compacting is done in the pressure range 20 to 30 kg per millimeter square. The pressure should not exceed the 30 kg per millimeter square values. Okay, maximum 30. This much amount of pressure is used, and by sufficient pressing, desired compact is obtained here. Okay, then if suppose you have added oil. Okay, one minute. You have added the oil, that oil will be eliminated. You have to perform one pre-sintering operation there, and during that pre-sintering operation, that oil will get eliminated. Okay, just a small pre-sintering operation is performed whenever you thought that there is some gravity segregation, and if you have added some kind of the oils, then only you have to go for this pre-sintering operation after compacting. If you have not added oil, if you see that there is a proper mixture is obtained, then there is no need to do this. And if this pre-sintering is there, then this pre-sintering operation to eliminate that oil, it will be performed at 400 to 450 degrees Celsius. Okay, and it will be performed for half hour to 2 hour, depending on that amount or volume of that powder used. Then after that, you have to go for sintering. Okay, now here, the sintering operation, here you have to heat the component at 800 degrees Celsius. Okay, here you have to heat the component at 800 degrees Celsius for 4 to 6 hours. Okay, for 4 to 6 hours in the reducing atmosphere, or you can say that in the neutral atmosphere. Okay, temperature is 800 degrees Celsius, and time required for this sintering is 4 to 6 hours. Then during the sintering operation, then the uh, diffusion will occur of that thin particles. Okay, diffusion will occur of that thin particles, and due to the diffusion, densification will occur, and after that, formation of new grains, that is recrystallization and grain growth, will take place. And during this, its strength and hardness will get improved, and porosity decreases in the sintering process. And due to there is some changes in the dimensions, due to the distortion or densification, after the sintering, you have to perform the sizing or machining operation on that component. And after performing the sizing or machining operation, with the help of a master die, or by directly performing machining operations, then you have to go for sintering. Okay, so this is the process. And after that, you have to perform the sintering operation. And after compacting, you have to perform the pressing operation. Okay, with the help of a master die, or by directly performing machining operations, that component is subjected to the testing and inspection stage. And in this testing and inspection, you can explain it with the help of the previous, that all kind you can add here, that is, it is tested for its tensile strength, compression strength, its hardness, porosity, density, then its microstructure, then it is inspected for its shape, size, or any kind of defect is there that you can mention here. Okay, so in this way, this manufacturing of friction materials or sintered friction material will take place in these stages. First stage will be powder production, second stage will be mixing or blending, then compacting or pressing, then pre-centering. If oil is added, you can mention here, if oil is added, then pre-centering is done. Then the final sintering or sintering process will be there at 800 degrees Celsius for 4 to 6 hours. Then sizing or machining, and after that testing and inspection process will be there. Okay, and in the compacting, you have to mention the pressure values, maximum 30 kg per millimeter square pressure. Okay, it will be in the range 20 to 30, maximum 30 kg per millimeter square pressure will be there. Okay, so in this way you can manufacture the friction material or sintered friction material using powder metallurgy technique. This diagram you have to draw it by taking the reference of the whichever symbols I have explained. All symbols I have explained there, and according to that you have to mention there, and you have to indicate the powders you have used in this first stage. Copper, tin, then copper and tin together 90, 80 to 90%. Okay, weight percentage will be there, and remaining lead, graphite, silica, and iron will be 10 to 20% by weight. Okay, then mixing will be there, uh, and maybe some oil will be added if needed. And compacting, here you have to mention the pressure, maximum 30 kg per millimeter square. Then pre-sintering, if required, is done at 400 to 450 degrees Celsius for a half hour to 2 hour, depending on the shape and size. And sintering 800 degrees Celsius for 4 to 6 hours. And after sintering, sizing and machining. And directly you can just write the machining also. Sometimes directly machining is done. And at the end, testing and inspection will be there. Okay. So these are the different stages. And at the end, you have to mention some properties of this friction material obtained. Okay, it will provide you sufficient coefficient of friction. Now sufficient coefficient of frictions will be there. Then it will provide you very good or sufficient amount of corrosion resistance, wear resistance, and it will have the very good thermal conductivity. Okay, so these properties you have to mention, and it will provide you that whichever properties are there, that is very good coefficient of friction at the higher temperature ranges also. That properties you have to mention there, and you have to mention some applications. Now this friction material or sintered friction material is used in the devices like clutches and brakes, which you are using in the different kinds of the vehicles. Clutches, brakes are there in that. Okay, these elements are friction materials are used in different kinds of the cars, buses, trucks, and tractors. Or you can say that in the automobile sector, in different kinds of brakes and clutches, these friction materials are used there. That you can mention in the application part. At the end, you have to mention that applications also, and flow chart you have to draw. Okay, in examination you can write on the one page here, can explain the stages, and on the another page vertically draw the flow chart, and at the end mention some applications. Okay, this much description is sufficient. Okay, now, okay, then the last component is there. Okay, I will wait for 5 minutes here, just 5 minutes I will wait, and after that I will explain it. Okay, just I have to that just now whichever parts I have explained, please draw the flow chart and send that flow chart to me via email, or that on directly on WhatsApp you can send that. Okay, now the last component is there. Okay, I will add that here. This is around. Okay. Okay, you can wait for a few minutes. Okay, I will start it, or you can take a 5 minutes gap also. Okay, till that I will add this, and you can complete that chart in this time. I will add these steps here. All right, like this, but you will not get confused. Okay. Okay, can I start if you are there? If you have finished the previous flow charts, can I start the explanation for this final component? Okay, please provide me replies. Okay, can I start explanation of this? The presentation is visible?
No, sir.
Hmm?
No, it is not visible.
Presentation is not visible. Wait, wait. I will reshare it. No problem. Nothing there. Wait, I am sharing the screen. Wait. Okay, is it visible now?
Yes.
Okay, okay, I will start now. Okay, now just this is the third component. This is the third and last component. Is manufacturing by powder metallurgy technique is universal levels. Okay, from these three components, any one component they will ask you. Just you have to memorize these stages and whichever powders you are using, along with the pressure and temperature values in the compacting and sintering processes. Okay, and if any specific operation is there depending on that component, that you have to understand the concept. Okay, and depending on these names you can draw the flow chart. Okay, now I will explain, these are the stages involved in the manufacturing of the cemented carbide cutting tools. Okay, cemented carbide cutting tools. Now the cemented carbide cutting tools can be manufactured here. Okay, this can be manufactured by for using these stages. Just you will find that more stages are there. Just what is the difference here? Whichever sintering operation is here, It involves three sintering operations: pre-sintering, preliminary sintering, and final sintering. Different temperature will be there, temperature zones. Then machining operations, two machining operations are there. That's why you are seeing more stages are there. Okay, you'll find that more stages are there. Just different operations are there, means types sintering, three types of sintering operations, and two types of machining operations, extra machining operations are there. That's why you will find it a little bit lengthy, but it is not lengthy, just different types are there. Okay, now we will start with the powder production. In the initial stage here, to manufacture the cemented carbide cutting tools, you have to use the carbide particles. Okay, different carbides of, you can go for carbides of tungsten, molybdenum, titanium, or tantalum, which are having very high hardness. These components carbides you can use there. Okay, uh, and generally we are using for manufacturing of cemented carbide cutting tools, we are using tungsten carbides and molybdenum carbides. Okay, and to provide the binding between these powder particles, you have to use the cobalt will be used as binder. Now this cobalt can be used, you can say that in the form directly you can go for the cobalt, or you can use its alloy. Okay, cobalt chromium alloy, or cobalt nickel and chromium alloy. Okay, either you can go for cobalt metal, or you can use cobalt and chromium alloy, or you can use cobalt nickel chromium alloy. Okay, now here, while choosing the amount, you have to take care that this carbide amount, 80% amount of carbide should be there, and 20% amount of this cobalt source will be there. Okay, if you have taken directly cobalt, then 20% cobalt you have to take, or if you have taken that cobalt in the form of its alloy with the you can say that cobalt chromium alloy or cobalt nickel chromium alloy, then 20% of that alloy you have to take. Okay, 80% of these carbides will be there, and 20% amount of these binders in the form of cobalt or its alloys you have to take. And we have to mention in the powder production stage only that all these carbides, tungsten carbides, molybdenum carbides, respective carbides, and this cobalt powder, all these powders are manufactured with the help of chemical processes only. And in that you have to mention that all these powders are manufactured with the help of reduction process. Okay, in that chemical processes, three types are there. From that you have to use the reduction chemical process. Just you have to do the reduction operation with their on their respective oxides, and you will get these powders. Okay, just you have to mention their amount, 80 to 20% will be their ratio, and these are manufactured with the help of chemical process. And in that chemical processes you have to use the reduction process. 1 minute, 1 minute. Okay, okay. Then this is your first stage. This is the powder production. Okay, you have to mention the powders required: carbides of tungsten, molybdenum, and cobalt powder or its alloys. And they, you have to mention their ratios: 80% carbides and 20% that cobalt or their alloys. 20% will be that. And all these are obtained, these which are powders we are using here, these are obtained by the chemical process known. And in that chemical process, a reduction chemical process you can use to achieve these powders, that you have to mention in the powder production stage. Then in the next stage, in the mixing stage, the uniform and homogeneous mixture of these will be obtained in the mixing process or blending process, by using different mixers or different blenders. And during this process you have to add some lubricants here in the mixing process. Now which lubricants we are going to use here? Lubricants are used here like you have to use the paraffin wax in the petrol. Okay, paraffin wax in the petrol, it can be used as a lubricant, paraffin wax in petrol. Or you can go for camphor in ether. Okay, paraffin wax in the petrol, or the camphor in the ether, or you can go for another lubricant, that is glycerin in alcohol. Okay, any one lubricant you can use, paraffin wax in petrol, or you can go for glycerin in alcohol, or you can go for camphor in the ether. Okay, these will act as a lubricant. Okay, these will act as a lubricant, and they will try to these will act as a lubricant, and they will provide the lubrication in the compacting or pressing stage. Okay, and here in the mixing you have to add these lubricants, and you have to try to get the uniform and homogeneous mixture with the help of different instruments like different mixers, different blenders. You can use Y-cone blender or double cone blenders are most commonly used for this process here. And after that, that uniform and homogeneous mixture obtained, that is subjected to the compacting or pressing stage. Here this compacting stage involves three stages, that is filling, pressing and ejection process. And while pressing, the pressure amount used, it should be in the range 35 kg per millimeter square to 45 kg per millimeter square. Okay, compacting you have to do using this pressure values in within this range only. Okay, you have to, if pressure is very less than this value, then you will get a fragile component, means powder will be loosely attached. It will get the powder will get removed after you eject that component. Or if you go for more pressures, then it may damage the tools or it may damage the dies used. Okay, then after the compacting, that compact, you have to do the pre-sintering operation at 400 degrees Celsius for half hour to 2 hour. And this pre-sintering operation, why you are performing this pre-sintering operation, you have added some lubricants here in this process, that is camphor in ether you have added, or glycerin in alcohol you have added, or you have added paraffin wax in the petrol. Any one lubricant you have to use, and that lubricants you have to eliminate in this pre-sintering process. Okay, when you heat that compact at 400 degrees Celsius, this is pre-sintering process for half hour to 2 hours, and that whichever lubricants you have added, they will get vaporized in this pre-sintering process. Then now this component is subjected to the sintering. Now in this cemented carbide cutting tools, sintering process is done. Two types of sintering processes are performed. First is the preliminary sintering, and next is the final sintering. Okay, now the preliminary sintering you have to perform at 900 degrees Celsius to 1150 degrees Celsius range. Approximately from half hour to 2 hours this preliminary sintering is done. And after this preliminary sintering, you have to subject that component to the final sintering in this temperature range 1350 degrees Celsius to 1550 degrees Celsius. Okay, now the both the sintering processes are done in the you can say that reducing atmosphere, or you can say that neutral atmosphere is used. And in this neutral gases, you can use the hydrogen atmosphere here. Okay, in presence of that H2 gas atmosphere, these two sintering processes are done. And in the final sintering, what will happen, this cobalt will start the melting. Okay, at this higher temperature range, in this temperature range 1350 to 1550 degrees Celsius range, this cobalt will start melting. Okay, it will start melting, and it will get diffused. It will get diffused on the carbides of tungsten or carbides of molybdenum. It will get diffused, and due to this diffusion, densification will occur. Densification will occur in that component. Okay, densification will occur, and due to that diffusion on the of cobalt particles on the carbides of tungsten or molybdenum, recrystallization or formation of new grains will take place. And this is the final sintering, which is performed for approximately 2 hours. And this cobalt will get diffused on the carbide and tungsten particle, and it will result in diffusion and densification, and finally formation of new grains will take place. Okay, that will be termed as recrystallization and grain growth process. Okay, and after this sintering, the component is subject, there will be some changes due to this diffusion operation. Dimensional changes will occur there. Okay, in that component, distortion in the dimensions will be there. Now this distortion in the dimensions is corrected by performing machining operation. Now here the machining operation is performed in two types. That is, the first machining operation or initial machining operation is termed, you can say that, initial machining and the final machining. And this initial machining is termed as rough machining, and this machining is done with the help of a silicon carbide grinding wheels. Okay, machining is done with the help of carbide grinding wheels. It will be termed as rough machining or initial machining. And after that, component is subjected to the machining is done with the metal bonded diamond wheels. That will be termed as final machining or fine machining operation. Okay, after that, here while drawing the flow chart, the symbol will be same. Just you have to mention the names and wheels used. Okay, silicon carbide grinding wheels and metal bonded diamond wheels will be used for final operations. And after this, you will get your component with the desired shape and size or in the desired dimension, and you have to perform the testing and inspection operation. The component is inspected for its shape, size, and whether any kind of defect is present in it, and it is tested. Okay, the testing operation you are going to perform on it. The testing operation is performed, and you are going to check its tensile strength, compression strength, its hardness, density, then its microstructure, then its porous, different properties you are going to check with the help of different destructive and non-destructive testing methods. Okay, in this way you will get that your final product. Now this cemented carbide you can use to for these cutting tools. At the machining operation, after performing these two machining operation, you will get these cutting tools. Okay, or different cutting operations, this can be used. Okay, these cemented carbide cutting tools can be used. At the end you have to mention its applications. So this is the manufacturing of this cemented carbide cutting tools. Okay, in this way, right now we have completed this part. Okay, now in this today's lecture we have completed. Okay, shall I continue, or we will stop here only if it is becoming a little bit heavy? Okay, why I have continued with two lectures. If all three components I finished in one day, you will understand it in better way. Okay, just symbols will be same. Just you have to understand the sequence of these operations and their respective powders or whichever parameters we have used in that respective stages. Just you have to try to remember that, and you have to draw the diagram and explanation. You can write it by your own only. Okay, if you are able to remember these parameters, then you will be able to write the whole process. Along with that flow chart you have to write. Okay, this kind of flow chart you have to write for all the components. Okay, for one component I have mentioned here. While sending you these PPTs, I will add the charts for all three. Okay, now what your work, you have to send all these three flow charts via email to me. Means I will understand what you have understood or what mistakes you are doing here. Okay, please complete this task. And some more part is remaining here, like some some advantages are there of this process, powder metallurgy process, and disadvantages and are there, disadvantages or limitations, and some applications you have to study. These are all applications which today we have discussed. All these you can write in the applications also. And some more applications are there that we will discuss in the next lecture. Today we have discussed the manufacturing of the porous bearing or self-lubricating bearing, then manufacturing of the friction material or sintered friction material, and manufacturing of the cemented carbide cutting tool in by powder metallurgy technique, and along with the flow chart. Okay, respective flow charts we have discussed their manufacturing and their applications also. If you are having any query or please mention that in the chat box, or you can ask directly. Okay, I will, please give me your replies. I will wait. Please mention your replies. uh, if you are having any query, you can ask that queries. If you are having or any suggestions related to my means whichever presentation I have made. Okay, if you are having any suggestions, any queries, you can mention that, or you can directly give me replies. Or if you have understood everything, you can mention that also in the chat box that you have understood everything. Then if you have understood, I will conclude this session. Please mention that in the chat box. Okay, please mention it. Okay, yes, Sagar, only few students are replying. Okay, please reply it, and please send me that whichever uh, flow charts you have drawn today. Please send me that. Okay, approximately only 25-30 students are there. Okay, okay, please mention that. And okay, now wait. First, I will stop the recording. Okay, few one discussion I have to make there. Okay, I will first stop this recording of this lecture. Okay, now in today's lecture, we have completed the manufacturing processes of the different components like self-lubricating bearing, then friction material, and cemented carbide cutting tools along with their flow charts. Okay, I will stop here. Thank you for attending this sessions. I will stop this.